Alright, in this video I want to go over the real number system, the natural numbers, the whole numbers, the rational numbers, and the irrational numbers. We're going to take a look at each one of these systems, and then we're also going to take a look at some brief examples of them. So we're going to start off with the real numbers. The real number system is one of the largest number systems in math. Basically, it can be thought of as any possible point on a number line or any number you can really even think of. So for example, 5, let me switch this. So for example, 5, 7, 312 is another perfect example. Also any fractions such as 5/10 or a decimal such as 2.347. Those are also real numbers. And now the real number system is made up of several other number systems such as the natural numbers, the whole numbers, the rational numbers, and the irrational numbers. So we'll move on to one of the next systems here. We'll talk about the natural number system. So the natural numbers are any of the numbers we use for counting. So for example, if you were to go to a grocery store and you wanted to look for apples, you would say, okay, I want to get 5 apples or 10 apples or 2 apples or 4 apples. But you never say that you want to get 0 apples. So the natural numbers are all the numbers from 1, 2, 3, 4, 5, so on and so forth, but they don't include 0. That's the big difference. It doesn't include 0. It's just 1, 2, 3, 4, 5, 6, 7, on and on, 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 on to infinity. The difference of numbers is the whole numbers. The whole numbers are just like the natural numbers here, except they include the number 0, and then they have 1, 2, 3, 4, 5, so on and so forth. So if we want to write this down, the numbers on the top, those are known as the natural numbers. And the numbers on the bottom, those are known as the whole numbers. Okay. And so we have two other number systems. We have rational numbers and irrational numbers. So we'll start with rational numbers. Rational numbers are any number that can be written as a fraction. So for example, let me switch back to white here. The number 6, which is a whole number, can be written as a fraction by simply changing it to be 6/1. Other rational numbers include any fractions. For example, 2/9. 5/17 is also an example. There are also decimals such as 0.4. There's also 2.57. That's another rational number. And then even repeating numbers like 0.4 repeating. Or actually, let me clear this out for a moment. For example, like 0.4 repeating are known as rational numbers. But then we have other numbers, such as the irrational numbers. Now, irrational numbers cannot be written as a fraction. And one specific irrational number that we know of is the number pi. And so pi is a number specific that it can be written as 3.1415 9, 2, and then it continues on and on. It never repeats. And since it never repeats, it cannot be written as a fraction. Not easily. And so what I want to leave off on this exercise is a couple of examples, and then we're going to have a nice little chart that'll help identify our number systems. So we're going to talk about the number 4. We're going to start off with some examples here. We're going to talk about 4, 4/9, 2.3, the number pi, and I'm going to redo that because that does not look good to me. The number pi, hard to type, and 0. All right. Starting with the number 4. It is a whole number, and I'm just going to write some text here. So the number pi is a whole number. It's also a rational number. And it's also a natural number. So 4 is a whole number. It's a rational number. It's also a natural number. It is not irrational because it can be written as a fraction. Now if I go to 4/9, 4/9 is a little bit different. It's only a rational number in this case. It is not a whole number. It's not a natural number because we can't count it in a grocery store. We can't get 4/9 of an apple. And it's also not an irrational number because it's clearly a fraction. The next one on our list is 2.3. 2.3 is a rational number only. It's not a whole number, it's not a natural number, and it's not irrational for the same reasons that 4/9 is. The next one is the number pi. And so pi is an irrational number only. It's not any other number. It's not a rational number, it's not a whole number, it's not a natural number. It's only irrational. And the reason for that is it can't be written as a fraction. So therefore it's not rational, it's not whole, it's not natural. Any of those cases. The last one on this list is 0, and that is both a whole number and a rational number. Yeah, and so it's not irrational because 0 can be written as 0/1. And it's also not a natural number because we don't usually use it for counting. We don't say we want 0 things. But one thing we do have to keep in mind is that all of these numbers, that's a fancy little bracket there to say all of these inclusively, are real numbers. These are all real numbers. And these real numbers, the real number system itself can be abbreviated as a special little symbol, which is basically an R with an extra little tail on it. I actually don't know the meaning of why we decide to use that identification, but that's what we use for real numbers. And so those are a brief set of examples that I wanted to go over, and then I want to leave you guys all with a little diagram. And I want to go down a bit more. Here we are. Okay, a little diagram. We're going to start off with one giant circle. And so this giant circle is going to represent all of the real numbers. And so inside the real numbers, we have two groups. We're going to have the rational numbers and the irrational numbers. So let me actually go ahead and remove this. Go ahead and start typing here. So this set is the irrational numbers. And then this set over here is the rational numbers. Now inside the rational numbers are the whole numbers. So inside here are the whole numbers. And then inside the whole numbers are the natural numbers. And so if you look back at the notes previously, you'll understand this. The natural numbers are the smallest group because they only include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. The whole numbers include all of the natural numbers, and then they add 0. The rational numbers are both the natural numbers and the whole numbers, but they also include all of the fractional numbers or decimal numbers that we can think of. The irrational numbers are not part of the rational numbers, and they're not whole, and they're not natural. They just live separately on their own. And that's a number such as pi, or if you know the letter E, Euler's number, it's also irrational and they live separately. However, all of these numbers are part of the real number set. And that is where we will end today.